Okay, this is an interesting projectile problem, and the book gives us two formulas for projectiles. I'm using this formula because our problem is in meters per second. There's a different formula if you're doing feet per second, so pay attention to the needs of the problem when you're doing this. So, a flare is fired upward with an initial speed of 294 meters per second. That's going to be our velocity. The balloonist is 2,400 meters high. That's going to be our height. He sees the flare on the way up and on the way down. So I like to, and then the question says, how long will it be before he sees the flare on the way down? So I like to sort of get a picture of what's going on here. So let's put this as our ground here. And we have a balloonist, right? Someone in a hot air balloon. He's up here. And I'm at the ground and I shoot up this flare and it goes up and then it comes back down. All right? The balloonist is at a height of 2,400 meters, right? I know in terms of height, so I'm going to say, what are the two times for the height to be 2,400 meters? So that's the height that the balloonist's eyes are at, let's say, right? And the velocity of the flare I'm shooting up is 294 meters per second. And I don't know the time yet, and then 4.9 t squared. So this is the basic problem that I'm solving. This is the constant for this type of projectile problem. You've probably seen it in physics if you take physics. So now I have to solve this problem. Well, there are two different times when the height of the balloon is so that the person in the balloon there can see the balloon or the flare go up. He sees it once on its way up and then he sees it again, how many seconds later. So what we're going to do is solve this problem. So first thing I'm going to rewrite it, putting the 4.9 on the other side. So I'm going to call it 4.9. Now it will be positive t squared minus 294t plus 2,400 equals 0. So this is the problem I have to solve, and I could solve this by factoring. It's a little bit messy because of that decimal point. So you know what I'm going to do? I'm going to divide everything by 4.9 so that I have t squared instead of 4.9 t squared. When I do 294 divided by 4.9, that comes out to 60t. And when I do 2,400 divided by 4.9, I get 500. So it's plus 500 equals 0. So now all I have to do is factor this problem here, and I will have my two answers for the times when the projectile is at the height 2,400 meters. So that's pretty easy to factor, right? How about 50 and 10 adds up to 60, so t minus 50, t minus 10. And again, if you don't know the factors right off, start with the 500, right? And just start making a list. 1 times 500, 2 times 250, 3 times whatever. And I realize that 50 is not too far from 60, so 50 times 10 is 500. So t equals 50 and t equals 10. That's seconds, all right? Now, how does that help us with the answer? Well, at 50, so at 10 seconds, right, he sees the balloon after 10 seconds. He sees the projectile. Then, at a total time of 50 seconds, he sees it again. The question is, how much time from the first time to the second time does he have to wait before he sees it again on the way down? And so the final answer to the problem is 40 seconds, because I have to subtract those two times, right? I saw it after 10 seconds, and I wait 40 more seconds, and I see it again, and the 40 more is 50. So it's a little bit tricky of a problem, but I think you can do it. And good luck with number 18. On number 18, you're going to use the other constant here, so you won't be using 4.9. Look it up in the book.